Hey folks, Quill18 here, and welcome to another episode of our Project SpaceCube, our tutorial where we're building a spaceship out of blocks in our game. Right now we have it so that when we click on the box, it does spawn another cube exactly where we clicked. Which, okay, I mean, you know, spawning cubes when we click on things is good, but spawning things exactly where we click is not. And really, we don't actually care where we clicked exactly. Like, we don't care about the actual coordinates into which the click happened. We care more about, well, which cube did we click on, and which side of that cube did we click on? Okay, we're going to go and spawn our new cube to offset in that direction. You dig? Well, this is actually a pretty easy thing to work out. So first of all, our spawn spot over here, we no longer want to spawn exactly where we clicked, which is what the dot point info is. That's the exact point at which our ray collided with, well, the collider. But the collider itself is connected to an object that has, say, a transform and a position. So if we do this, now when we click on the cube, it's going to spawn new cubes in exactly the same position, which means, well, we don't see anything, but, you know, it's happening. Okay, that's fine. And you do have to trust that it's not just spawning it at, say, the default 0, 0 position. It is spawning it wherever the cube we clicked on is. Just so happens that cube's currently at 0, 0, but, you know. Moving on. So how do we figure out that whole thing about, well, we want to know which side of the cube we're clicking on, and then sort of offset things in that direction. If we clicked on the top face of the cube, for example, right? Where's my window? There it is. If I click on the top face of the cube, then I want our new cube to spawn upwards by 1 unit. Right now, we're just going to assume 1 unit because our cubes are 1 unit. Later on, we'll come up with something a fair bit slicker. Don't worry about that. So how do we do that? Well, our hit info has something called the normal. This is the normal vector to the face that was clicked on. Basically, if you look at like a tabletop, the normal vector would point straight up out of it. Okay, and it doesn't matter what angle you angle the tabletop, the normal vector points directly away from that surface. Well, that's quite cool because it means if we were to click on the top face of the cube, the normal vector would be a vector with, that would be x equals 0, y equals 1, z equals 0. Because it would be a vector pointing straight up. A normal is always going to be a unit vector. It's going to have a magnitude of 1. It's already normalized for us. But yeah, it will have a direction that is basically normal or perpendicular if you want. Although does the term perpendicular really apply to faces? I guess maybe, I don't know. It'll point away from that, which is cool because we can use that to offset our cube. We'll spawn our cube at the same position of the cube we clicked on, offset by that normal vector. We're not going to use the solution later on, but it's a cool trick for now and something that you might use depending on what your projects are. So what we're going to do is our spawn spot is going to be the position of the cube plus the normal vector. All right, let's try that and see what happens. We're going to go over here, hit play. I'm going to click on the top face of the cube. Ooh, now I'm going to click on the left one over here. Top, here. How about going forward? Oh, that's brilliant. Love it. Fantastic stuff. Oh, just lovely. Okay, that's really cool. So we've got the cube problem solved. Well, we have the 1 by 1 by 1 cube problem solved, but you know, let's just put a pin in that. Now let's try a slightly different shape. We've got a cube. What we're going to want to do now is we're going to start wanting to work with thrusters. This is going to be a spaceship game, so we want to be able to glue a thruster on there. So first thing we're going to do is we're going to make a prefab out of this because this is just the model itself. If we drag it into the scene, what we're going to end up with is a game object with the mesh render and the mesh filter. Now, what I'm doing here, I'm going to tell you ahead of time, spoiler alert, this structure is bad. With the way the cube and now the way the thruster is organized, it's very bad. We're going to be redoing it. We're going to be nesting things inside of game objects later on. But for now, we're going to be okay. All right, so this is good. Let's go ahead and we're going to make I'm going to rename this to thruster, which looks better, and I'm going to make a prefab out of it by dragging it over to prefab there. Excellent. Now I'm going to delete the thruster out of the scene, and what I'm going to do is our script over here, the prefab to spawn, I'm going to replace it with the thruster prefab, and right away we're going to start seeing some weirdness. I'm going to hit play. I'm going to click the front face. And okay, that's interesting. That's not exactly what I was planning. What if I hit the top face and the side one? Okay, right away we can see a few things. few things going on right away. And it's clearly a little clear to see in the preview over here. First of all, it's interpenetrating our previous image. Why is that? Let's figure it out in a moment. Secondly, these thrusters are clearly not rotating to match the orientation of the face we're clicking on. Actually, what's weird, and you might be like, yeah, that is really weird. If you look at, this is our normal prefab in the scene here that I just dropped in. This is what it normally looks like, pointing this way. And then when I hit play, and I click on any one of these faces, why is this thruster orientated differently than this one? Well, the reason is, it's a couple of things. One of the side effects of working in Blender and Unity is they actually use slightly different coordinate systems. In Unity, Y-axis points up, Z is considered the forward axis. It's sort of away from the camera. Whereas in Blender, X and Y are both flat to the ground and the Z-axis is up. Plus, I think they invert like right-hand and left-hand coordinate system. As such, when you import something into Unity from Blender, it's always got this rotation, this negative 90-degree rotation around the X-axis. I actually don't know why it's not exactly 90 degree in this case, but that doesn't matter. Well, so normally it has that. And note, when we go and spawn this, right now we're saying we're instantiating this object quaternion.identity, which means no rotation whatsoever, which is why when I hit play and I spawn something, this new clone comes in with no rotation whatsoever. So right away you can see a mismatch, and that should give you a clue that, okay, there's something about this structure that we're using isn't quite right. What you should always, always, always do, or never, never, never do, maybe is the best way to say it, is your visual information for your objects, your mesh and mesh render and all that, should never be on the root layer of your object. What do I mean by that? Well, I'll tell you what it should look like. We're going to create an empty over here, and just for sanity's sake, I'm going to go and center it. Then I'm going to take the thruster and put it inside here. I'm going to rename this object to something like graphics, right? Or tell you what, I'll call it thruster graphics, and I'm going to call the base game object just thruster. And then probably we'll want to recenter this. Now, by doing this, we have the advantage that the new thruster object now, let me delete the old prefab. So this is the new prefab here. And this new prefab has no rotation. Its normal orientation has 0 rotation because it's the child that's rotated. And the upshot of this is, if I were to go and remove this and go back to my scripts over here and drag this new thruster prefab into the prefab to spawn, when I click, now the thrust orientation is exactly the same as before, which is better. I mean, it's not fixed. There's still something going on here, but this seems to be a little bit better than what we had going on before. Okay, so, but we still have the interpenetration problem, right? If I click on the front face, you can clearly see that this thruster is sticking into the box. Well, that's the other advantage of this setup. Let's say I take this thruster prefab. Let me center it like this, and then what I'm going to do is I'm going to drag it -1 in the Y. Actually, do I want to go it this way or the other way? Let's do it this way for now. It's fine. So now my base object here, my base game object thruster, is at 0, 0 with a Z of -1. It is 1 unit closer to the sort of the normal camera, which, and we've got a camera offset, but you can clearly see that, right? So as I go -Z, it's pulling away this way, and positive Z is away in the distance. So if I set it at -1, this is the coordinates that should happen when the thruster is glued to the top of the front of the box. But it's clearly sticking in a little bit. Well, again, that's where the fact that your model is a subcomponent of this larger object, you can then go and offset the model like this. So now correctly, when the thruster at 0, 0, -1, it is correctly not interpenetrating the box. So we've got our organization correctly. And that's because when I modeled this object, you know, I may have had it offset, or the center point may have been a little bit different. There's lots of different reasons. But my nesting in here were great. And I'm going to go and apply this. And now, when I go and hit play, and I click the front face of the box, everything is good. Now, if I click the top face of the box, we still have the issue that the thruster's not rotated based on what face we click. It just so happens when you click the front face, the orientation looks reasonable, but all the others seem kind of off. So how do we fix that? Well, with our current setup, we're going to go back to our friend normal. Normal is a vector that points away from the face that we've clicked on. And that direction should represent the direction that we want our thruster to be rotated to. Good, how do we do that? Well, when we spawn our object, well, okay, hold on. When we spawn our object here, we feed it in a rotation, right? We've got the prefab, we've got the position, and then we've got the rotation over here. So we've got a spawn spot. What would you like? So Quaternion, we want a spawn rotation. But what is that? Well, you can't just say hit info.normal. The reason you can't do that is because this is a vector that describes a direction, and Quaternion describes a rotation, right? A direction with the, say, when you're pointing straight up, for us might be the case where we are rotated 90 degrees around the x-axis, right? If you're, let's say normally you're facing forward and you want to look straight up, well then you're going to rotate 90 degrees until you're looking straight upwards. So a rotation of 90 degrees equals a direction vector of 0, 1, 0. So they're not the same. Can you go from one to the other? Well, normally here's the way you could create a quaternion, right? You can go new, quaternion like this. You can create, like just this would be the no rotation one, or you can feed it in this X, Y, Z, W nonsense. Quaternions are not vectors. They have 4 components, and they don't describe things in the way that you would intuitively know. Quaternions are not really intuitive in the same way that vectors often are. And to instantiate a quaternion with this X, Y, Z, W often is not the case. In fact, I don't know if I've ever done it. I have gone quaternion as, oh, God damn it, as a class, typos, as a class has these static functions that you can use for a variety of things, including a few that will create a quaternion for you. For example, the quaternion.Euler takes in a set of 3 rotation values in X, Y, and Z. You can either feed it a vector, or you can just feed it the floats directly. These would be in degrees, and so if you want to look straight up, for example, we could feed in this over here. That would be one way of creating it. That's a lot more intuitive. But here we still don't have angles. We don't have degrees. We have a direction. Luckily, we have a way to do that. There's another helper that says from to rotation. We say, listen, we have an object that is pointing, say, forward, and there's a little helper for that. Vector 3 dot forward. We're to assume that forward is the normal orientation for all of our little components, all of our little bits and bobs that we're going to be making our spaceship out of. We're going to assume that we have gone and arranged them all so that if you don't do anything, if you just like drop them into the scene, they will be correctly pointing forward, which actually our thruster is not, as we're about to find out. Then we want to rotate it to point in the same direction as hitinfo.normal. And what this will return is this will return a rotation that describes moving from one to the other. In the example of hitinfo.normal pointing straight up, this will describe a rotation that will take you and then point you straight up afterwards. And you know, if we then went and turned this into the spawn rotation.Euler angles, this would be 0, 90, 0, like that. So now we have a rotation, and we're going to go and feed that into the instantiator. And as we're going to see in a second, we do have something a bit backwards, but most of the way there. If I click on the front, okay, you can see, yeah, my thruster is pointing backwards, but no matter what face I click on, it is pointing backwards along that face. Hooray! Now, why is it pointing backwards? Well, again, I said this is assuming that all of our models are facing forward. Well, this is not, because I mean, it's a little counterintuitive. In a sense, it might be fair to describe this back end as forward, but it's not. Remember, we're turning everything so it's facing in the same direction as the normal vector. The normal vector is facing outwards from this. And our front side is this part over here, right? Front is always positive Z. Positive Z is out in the distance. Way back over here is point positive Z. So the front part, or rather the part that's supposed to stick out from the object, has to point positive Z the way we've got it. You could easily invert this. You could just, you know, put a little negative, whoops, put a little negative here, there, and then all of a sudden that would work perfectly fine, right? If I just do that, hit play, hey, we're good. But I don't think I like that. I don't think I like that at all. I think it would be better to look at this and be like, oh, right. So the bit that's supposed to point outwards from the box is supposed to go positive Z. And again, this is the advantage of having your graphics inside, because now I can take this, rotate it 90 degrees, 180 degrees around the y-axis. So now it's facing the right way. I'm just going to go and move the thruster. I'm going to make sure that I'm going to put it positive 1Z, and then just make sure to offset it again. Okay, we gotta fix it for this side of things, and that looks pretty good. So what I'm gonna do is apply this. I'm gonna delete the one in the scene. I'm gonna hit play, and now when I click on the face, it should correctly be facing outwards no matter what face I click on. Fan-freaking-tastic! That looks exactly like what we're hoping for. Very, very good. Okay, so that's great. Now, right now, if I were to click on this, nothing would happen. Actually, better example is, let's say I were to click right here, right here. What do you think is going to happen? Well, it's going to spawn a thruster, and another one, another one, another one, and another one. What's the deal with these thrusters it's spawning? Well, as it turns out, we're spamming a bunch of them in the same place over here. Why is that happening? Why is it that when I click here, it spawns another thruster in exactly the same location as one that already exists? Well, the reason is that our thruster here doesn't have any colliders. When we do our raycast, the raycast is part of the physics system, and therefore it only hits things that have colliders. Our thruster does not have one. So, do we want to add a collider? Well, probably. I mean, we don't want our clicks to go through the collider, hit the box, then spawn another thruster here. Now, internally, we could do a whole bunch of stuff to keep track of, oh, does this spot here already have an object in place, in which case don't spawn? Yeah, I think it makes sense for this to have a collider. I mean, in our physics engine, we probably want things to bounce off this thruster from time to time. Maybe it can take damage if a rock hits the thruster. So it should have a collision box. So let's go ahead and add that in. Well, so there's a couple of different ways that you could add in a collider. We could do a actual box collider, right? And the box collider is quite nice in that when it spawns, it automatically tries to figure out the bounds of the geometry, and so you'd have a box collider there. And I mean, I guess that would be okay, but it's not really tight to the model here, is it? And depending on what kind of game you're trying to do and what kind of precision level you're trying to do, often this is perfectly fine. One of the advantages of box colliders is that they're incredibly fast for the physics system to deal with. It is a simple shape that allows a lot of optimization because of the way that the physics engine knows how a box works. Spheres, I think, are equally very, very, very fast because it's very easy to just basically treat it as a radius coming out of a point. Makes the math easy. But let's say we wanted a more precise collision model. So instead of a box collider, I'm going to go and remove that. And I'm going to put on a mesh collider. A mesh collider requires a mesh. Just like our mesh renderer requires a mesh filter with an actual mesh as part of it, the mesh collider also needs one. Now, if you add a mesh collider to a game object that already has a mesh filter, then the mesh automatically gets filled out, as you can see here. My quote-unquote cube. In Blender, this thruster was built from a cube. That's why it's called cube over here. I'm sorry that that's very confusing. My apologies, but that's why you're seeing cube up here and cube down here. Now, if you were putting the mesh collider on something that in and of itself, that game object doesn't directly have a mesh filter on it, you could still just manually assign a mesh by going into here. You can see all the Unity primitives are available as options in there. Okay. So we got this mesh collider. If I go and turn off the mesh renderer, we can clearly see the green lines of the mesh collider over here. Now, you don't always need, even if you need something more precise than, say, a cube, you may not need something that's literally quite as precise as this mesh. Also, if you have a really complicated model, sometimes you will go and you will actually, in Blender or your 3D program, make a low-resolution version of that mesh to use as a collider. The other thing you can do is set it as convex. Convex will make it so that it doesn't have any concave bits that stick in. Again, that makes things much, much, much faster to calculate. Also, it's worth noting that non-convex mesh colliders, right, the ones that don't have that checkbox on, can't collide with each other. And there's a few other rules going on in there. But in this case, I'm going to call this perfectly fine. You know, we'll have a nice high-resolution mesh that is very accurate. That's going to be groovy. Okay, so now that I've done that, I can go and apply the changes to prefab. Now if I hit play, click on the front face of the box here, boom. Now when I click again, the raycast isn't going to go through my thruster and hit the box, which means we won't spawn another thruster in the same place. However, we will spawn thrusters in sort of awkward orientations over here. Why is that? Well, because we're still spawning things, right? We are putting out a raycast, we find out whether we hit something, therefore we spawn something on it, and we rotate it based on the orientation of the normal. And right now we're just offsetting things by the normal unit vector, which means that there's gaps and things like this. Again, obviously, we've come back to something that isn't quite right. This is not what we are looking for in the end. So how do we make it so that we don't just ignore the thruster and let the ray go through to the box and spawn something, but also we probably don't want to spawn something on the thruster itself? Well, then there's a couple of different ways of doing that. What we can do is we could give the thruster a different layer and have some layers be responsible for spawning things, other layers not responsible for spawning things. We are going to do that in a moment. That is absolutely something that we're about to do, but not quite in this video. But that is one solution. The other thing you could do is you could have your object have some sort of component on it, and you just check for that component to exist. That's fine. Oh, the other thing I want to note, look at the log here. When we click, what are we actually hitting? We are hitting, so here we hit cube. Here we don't hit thruster when I click. We actually hit thruster graphic, because the thruster graphic is the thing with the collider on it. We could put the collider on the base object itself, but I find that might work fine if you're just using a cube collider or a sphere collider or something like that. But in case of a mesh collider, usually because the mesh collider matches the graphics, it usually makes much more sense for the mesh collider to be part of this graphics layer, especially if you're having to do things like this with like a little bit of an offset and a rotation. Then really you need the mesh collider to be part of all that so that it stays properly in sync with the graphics. How do we get the base object here if we wanted to not be attaching things to thruster graphics, but instead be attaching things to the thruster itself? Well, it's quite easy to do. When we hit the object, right? So we have over here, game object we hit, right? Right now, basically, we're just using hitinfo.collider.gameObject, right? That's sort of what's going on in this whole series. Well, instead of doing this, what I can do is say, this hitinfo.collider, the transform of this, what is the root object of this series? And this becomes very important if you have a lot of nesting. So because you could have something like thruster assembly A, side panel B, and then you have the actual like box that is part of the graphics or something like that. Like you can have a really complicated nested image. That becomes especially prevalent with like a lot of like humanoids, where you could have like sort of the skeleton, and on top of that you have sort of like the chest skin, and then on top of that you have a jacket, and on top of that you have like a bandolier for bullets, and those are all sort of submodels that are all connected and moving together in the same sort of skeleton assembly. But they're different sub-objects, and you may want, you know, the colliders, each one of those might have sub-colliders, or there could be a lot of different things like that. So, oh, yeah, .root, .gameObject. Oops, .gameObject. I was getting a little error there. So there are many ways that you can sort of filter out, you know, undesirable objects that you don't want to click on. But a better way might be instead to use that common little node system, right? Which you're used to seeing these sorts of things, where you have like sort of a little indicator on one of these sides that says something can be attached here. And this becomes especially important if, instead of using the thruster graphic here, for example, we use the triangle. So again, what I'm going to do is I'm going to make one of these prefabs. I'm going to make, first of all, an empty here. I'm going to call this one the triangle, and I'm going to stuff the model inside of it. I'm going to set the triangle to +1z over here, just like the, how come it's oriented that way and not this way? Oh, no, it is correct. It's just that my graphic. So my actual game object is offset in the Z by a point of 1. And what I need to make sure to do is to take my model here and orient it so that it makes sense. So for example, I'm going to, rotate this 90 degrees this way because I want this part back here to be the flat bit. I'm going to go and move it, but then I'm also clearly going to have to shrink this down. So let's grab this scaling tool to scale it in every direction, and we end up with something that looks pretty good. And from the side, let's bring that up that way. And it looks like, we have to squish it in just a little bit more, and it's still slightly too big. What if it was exactly, any chance it's like exactly 0.5? Is this what we want? Oh, it is. Okay. So I just made this triangle twice as large as it was supposed to be. There we go. Something like that. So now it lands nice and flush. Oh, not quite. Check the top again. It looks like we have to move sideways slightly. Like that. Ooh, maybe a little more. If I had drawn these models correctly, I wouldn't have to worry about it. Looks like if this were set to 0, it feels like that's pretty good. And I'm betting the Z at negative 0.5 is exactly what we want. And man, why is it offset just slightly? It must be a floating point error or something like that. Okay, that looks... Oh, no, then it's too tall. Okay, so it's not exactly on one of the sides. There you go. So yeah, the Y does have to be offset a little bit more than expected. I'm going to call this good enough. All right. So we've got this part over here. Let me go and turn this into a prefab. And I'll delete the instance of it in the level. And then I'm going to, on our scripts here, the prefab to spawn, I'm going to set it to the triangle. And we're going to hit play here. And I'm going to click here. And then I'm going to click, oh, it doesn't have a hitbox. Here, 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 we're going to use a mesh collider. It'll pick up the model correctly. Excellent. Now I'm going to apply these changes to the prefab, delete the one that was in the level. Try this again. Let me click on the top, and then here, and then here, and then here. Okay, so this is a good example. See these gaps here? Why is that gap happening? Right? Let's hit play, click here, click here. Why is that gap happening? The angle is correct, right? The angle is correct, but why is the gap? Well, it's because we are placing this triangle offset by the normal from, well, kind of the center of this triangle, which is why that's not quite correct, is it? So there's a few things, like we actually want this triangle to spawn flush, not 1 unit away from the center, which is what our current offset. Our offset is this hidinfo.normal. We are offsetting by 1 from the center of the thing that we clicked on. So we don't want that. We want it to be, basically, we want to spawn flush here, which again makes you think, oh, should we be using hidinfo.point again? Well, hidinfo.point would correctly give us something that would be flush to the surface, but then the problem would be if I were to click off to the side, then our object would be offset to the side as well. So we start to hit that point of, how do we get the correct position that we want? Now, there are ways to do some calculations, like what you could do is use the hit point to find out the actual point that we clicked, and then look at the normal, and then make sure that we are centered on the object except in the direction of the normal. Like, there's a few things you can do, I guess, but it feels kind of awkward. What I think it is time for us to do, it is time for us to go and make those little, what are we going to call them? So let's say I make another, say, cube over here. And I shrink this one down to like 20th of the size, and then like offset it like this, right? This little click node point. Right now, instead of using the entire box as a clickable area, what if we use these nodes here as the clickable areas and have things spawn at the sort of center point of this area? And as long as the center point is correctly flush to the surface, then if we spawn something using that center point, then we will be correctly flush. Now for the cube, it doesn't matter so much, but for the triangle, what if we go and duplicate you, drop you down in here? So this is like the, I don't know, click point? Let's call it like the snap point. I think that makes sense. That's the thing, the point at which something snaps on, right? And then we were to bring it out here, something like that. I mean, I'm just eyeballing things right now. We're gonna have to do this better. But now all of a sudden, if this is what we're talking about, then again, we use the position of our snap point as the spot at which we spawn the new object. Not only that, but we can use the rotation of this cube here as the rotation of our new object, which is important because imagine you were to click, it's fine, if you click on the front face over here, then your normal would be pointing in the correct direction to spawn the object. But what if you click here on the snap point? Well, you don't want the object to be sideways at that point, no. So we actually aren't going to be using the hit point.normal anymore to determine the rotation of our newly spawned objects. Instead, we're going to be using the rotation of these snap points. So we're going to be using the position of the snap points and the rotation of the snap points. That's also quite important for maybe we don't want to be able to attach any object to the side of the triangle. That's something we hadn't looked at yet. Maybe only certain places are going to be legal snap points, for example. So on the triangle, here and down below. Some objects may even have more than one snap point on their face. In particular, that would be important if Imagine, so we've got our big cube over here. We've got this. Imagine we had a version of this cube that was twice as long, right? Then again, you don't want to necessarily just snap things to the middle as before, whereas instead, you may want to have a snap point here and here, for example. Starts to be a lot of interesting possibilities once you use the system, which is why most people use the system. And that's what we're going to look at implementing next time. Thanks for watching, folks. See you then. Thank you to all our September patrons, i.e. people who've pledged in September and are supporting the videos from October to early November, and especially these Mike Check supporters. We've got Yuko Finn, Ole Peter Talgo, Adam Conway, Drazian, Jan Torrevel, Adjective, Michael McClintock, Aaron Doibson, Craig Mortel, Stephen Wendell, Julien Auger Lafont, Marius Fieldvold, Speedy Savant, Stephen Stager, Valiant Cake Fiend, Wes Olenboving, Jason Yanity, Kale the Quick, Neil, Blakey, Milner, and everyone who's watched, shared, favored, and subscribed to the series. Thank you very, very much.